What's up, guys? Welcome back. Dr. Jaws here, and tonight we are diving into the deep sea to meet the Dwarf Lanternshark, Etmopterus perryi. So this is one of the smallest sharks in the world, if not the smallest shark in the world. I think there's a couple species, and I believe they're all lantern sharks, that can kind of contend for the title. But even so, it's going to be really cool to take a look at this species and also take a look at other denizens of the deep. We've got a lot of really cool footage. Hey, Howard, welcome back. It's good to see you. How are you? Hope you had a good weekend. We're taking a look at this deep sea species. Quackers, what's up? Quackers is back as well. What's up, guys? Hope you had a good weekend. Hope you guys had some fun summer activities. This weekend for me was pretty relaxing for the most part. No ocean things, but just kind of like a nice kind of break weekend because we've been just running around a lot the past couple weekends. So nice to kind of take it easy, but it's really cool to dive back into the deep sea. I feel like we've been doing a lot of shallow water sharks lately, so it's really cool to see or go back into the twilight zone and to meet this species, and also just take a look at the deep sea environment in general. So I mentioned it a couple times on the stream, but there's a lot of really great channels on YouTube that explore. Oh, there's a shark. There's a blue shark. Look at that. So Prionis glauca, blue shark can occur, I think, in all three major zones, like the sunlit zone, twilight zone, and midnight zone. But this is more famous for being an open ocean predator, kind of cruising the shallow open seas, or not shallow open seas, but like just like the upper part of the water column. But it's really cool to see like sharks like that enter the twilight zone. So. Howard, I'm so glad you're feeling better. I'm really happy to hear that. So really glad you're feeling better. We missed you. And Quackers, yeah, miss you as well. I'm sorry that your computer has been a little iffy. If you don't mind me asking, I'm sorry, computer access. Never mind. So, we were, my girlfriend and I were talking about computer brands, and we were kind of like reviewing like what are good ones and what are like not so good ones lately. So I was going to ask if it was the computer itself, and if you have any recommendations, or if you guys have recommendations in general about good computers, because I'm a big Mac person. I know not everybody really is, but like I really love them. But then when it comes to PCs, I'm not as familiar. So like Lenovo, I've heard is like, I've had weird experiences with them, but I've heard they're good. There's like Dell, there's Asus. So if you guys have any PC recommendations, please leave them in the chat, because I'm kind of curious. Also in the background, as you can see, we have a lot of cool deep sea wildlife from one of those YouTube channels I was mentioning. This one is the Monterey Bay Aquarium, which we've seen before. But then there's also Nautilus. EV Nautilus is a really great deep sea stream where they kind of like summarize what was I gonna say? It's like summarize your expeditions, like kind of like break them up into kind of digestible clips, because and they're usually like an hour long or even 2 hours long, so they're really cool to have on in the background. So Minjus, welcome back. Good to see you. Good to see you as well. Man, a lot of our favorites are here. This is so cool. Hope you guys are, Quackers and Howard, hope you guys are participating in the contest. And Minjus was here last week, and I think the stream before, so we talked about, we have the Shark Week contest, which has an extended deadline. Or not extended deadline, it's a pretty big deadline. July 21st, so it's our annual YouTube banner contest. So let me know if you guys have any questions about any of the rules. Oh, okay, yeah, Quackers. I think what we'll do is I'll hop on over really quick to just kind of. Oh, this is really cool. A rat-tailed fish. I'll hop on over really quick to the main Dr. Jaws YouTube channel page to kind of explain the contest rules. Go. All right, here we go. So this is our second year, which is kind of cool because like we did this contest last year. Our very own Howard Kerr was last year's winner, the 2023 Shark Week winner, and it's the Shark Week banner contest. So you can see on the main channel page, the goal is to create a YouTube banner for the Dr. Jaws channel. The winner will have the banner displayed on the channel for an entire year, plus a copy of Sharks of the World, the Pocket Guide to Sharks of the World, by Ebert. I have this right here, actually. Ebert, Fowler, and Dando. This is a really great, handy reference. Plus a copy of the Bull Shark Compendium. This is the latest book that is authored by myself. And then finally, a genuine fossil Carcocles anguistidens tooth. All of this will be mailed directly to you, the winner of the 2024 banner contest. So the rules are just to create a YouTube banner. Bonus, I think I had the summary on the community channel. Let's see. Dun, 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 dun. There we go. Okay, yeah, Shark Week banner contest 2024. So those are the prizes, Sharks of the World, and then the Bull Shark Compendium. I had the description here. Oh, there we go. Okay. So yeah, create an original piece of shark art that could be used as a YouTube banner. Ideally, the ratio is 16:9. It's totally okay if you've already started an art piece and it's not 16:9 ratio. I love just like art and kind of like photo editing. So if you have whatever size illustration that you have, I'll be able to play with it and create a really cool banner out of it. So ideally, if you're just getting started, the 16:9 aspect ratio is ideal. That's like the ideal size is oh my gosh, 2560 by 1440 pixels. But if it's not quite that large, or if it's like a different aspect ratio, that's totally fine. Everything is welcome. So because I'll be able to edit it later. So, but yeah, submit the artwork as a JPEG, PNG. I mean, GIF works. GIF does work. I've never tried it, but I've heard that the YouTube banners do work on GIF or GIF or BMP. I personally prefer JPEG and PNG, but GIFs are totally fine. But please send that to drjawssharks@gmail.com by Sunday, July 21st. So literally by, let's say, like 8-9 p.m. Sunday. I probably should edit this to give a time, but Sunday, July 21st. Submit your email with the header Dr. Jaws YouTube contest along with your YouTube name. This is only for subscribers, so just leave your name in the header so I know who's who. So subscribe. It's only you have to be subscribed to the channel in order to participate. And the bonus is all shark art is welcome, but special consideration will be given to entries that either celebrate the channel, like our community or some of the species we covered, or incorporate a theme of shark conservation. I feel like 2024 has been a really great year where we've been focusing more on conservation. Last year was kind of, the theme was like biodiversity, and also we covered a lot of lamniforms like the mackerel sharks last year. This year I feel like we've kind of distributed our species coverage pretty well, and then on top of that we've been going into the conservation issues a lot more, which is really cool. So, and then here's the prize. The books, the Carcocles anguistidens is also known as Etmopterus anguistidens, aka a megatooth shark fossil, and then your artwork showcased as the banner for the entire year. And again, shout out to Howard Kerr, who was 2023's winner, maybe 2024's winner, but I've heard that I know there are some other people participating, which I'm really excited about. So it is going to be a contest, like an actual contest. So very, very excited about that. So let me know if you guys have any questions, and yeah, I'm excited too. So to see what everybody makes. So. Oh, and Quackers, yeah, I just saw that. It looks like Nautilus. Yes, Nautilus is such a great YouTube channel for deep sea wildlife. So, kind of want to finish this, just kind of like taking a look at this footage, just to kind of get like a vibe of the Twilight Zone. It's really cool. Oh, yeah, go for it, Quackers. Anything is welcome. Anything and everything is welcome. So I'm really excited just to see what everybody creates. That's probably what my favorite parts about like our community and the channel is. Like I really do love seeing everybody's like original pieces and original artwork. It's a lot of fun. And I'm really excited that this is the first contest we did for 2024. We did a couple for 2023. I've personally been running around a lot, so I haven't been able to organize one for a while until now. So it's Shark Week, or we just finished Shark Week, but it's Shark Month essentially. So very excited to get going on this. So super excited to see what you guys make. But by the way, I've never seen this before. Owlfishes. I have never heard of this. This is a brand new group of fishes that I had no idea existed. Let me rewind really quick on this, because this YouTube footage is really cool. Owlfishes, wow. Huge eyes. Like enormous eyes from the size of the head. They're kind of cool because they look like minnows almost, except for they have two dorsal fins. And pretty proportional scale. So cool. Humboldt squid. This is an infamous squid that there's legends of it. Oh, sorry. Could you type the name and say it again? Owlfish. So yeah, owlfishes. Sorry about that. But Humboldt squid is a very infamous squid. This species, allegedly it kills people, but I'm not as familiar with squids, so I don't really know the actual what is like a legend and what is like actual fact as far as squid human interactions. But Humboldt squids are really large. I believe they occur in Baja California or this southwestern California, I believe, is where you can find Humboldt squids. But I've heard of them being kind of dangerous as far as and I don't know how much of that is modern myth or how much of that is no, that's an actually dangerous species, because they do come up at night, and I think I've heard of incidents with Humboldt squid. So yeah, it's really cool to see the squid footage. What's really exciting and a little scary about squids is that they are very smart as far as they're cephalopods. I know octopi are usually regarded as the smartest invertebrate, but squids are pretty smart as well. Ooh, the swarthy snaketooth, pretty cool. So, oh, look at that distended stomach. That's super cool. A lot of Twilight Zone animals do have the ability to expand their stomachs because finding a meal is so hard in this vast environment. So once they capture something, they're able to dislocate their jaws or expand their stomachs to contain whatever food that they can find, and they are able to live off of that for a very long time. This is a new species of anglerfish I've never seen before. Wow, a lot of cool stuff. The Pacific viperfish. Look at those fangs relative to the body size. And it's kind of cool to see in this collection mostly bony fishes. We only saw that blue shark in the footage, unless I missed any when I was... no, actually, no. Yeah, I didn't miss any. Oh, the black dragon. These are cool. I love the angler. Or sorry, the lure. Sorry, the lure. There we go. The lure on the chin. It's such a cool look. But it's kind of cool to see whoa. It's kind of cool to see the deep sea. There's a chimera. There's a relative of a shark, the long-nosed chimera. It's kind of cool to see the Twilight environment and see, the home that is shared by a lot of deep sea sharks. And honestly, I think you can make an argument that most sharks, at least as far as biodiversity or biomass, are deep sea animals. They're not really, or at least for the dogfish. This is a beautiful feather star. At least dogfish or squaliforms, which is what the lantern shark is a part of. They're very unusual. It's very unusual to see squaliforms in shallow water. They're really deep water species. So things like the pike dogfish are very unusual to see in coastal. The fact that it's a coastal dogfish is kind of a strange thing as far as sharks go, because most of them are deep water animals. So, and I think you can make an argument that most sharks are deep water because some of those speciose groups, like the dogfish or the cat sharks, they all live in very deep sea environments. So I think there's an argument to be made there. But got a snailfish. I believe snailfish as a group are one of the deepest dwelling. Oh, there's another chimera. So snailfish are some of the deepest dwelling animals in the world. I think the Mariana Trench has snailfish because there was some footage collected. I believe it's like the James Cameron like expedition to the Mariana Trench. Oh, this is a good shot of the chimera, by the way. This looks like a comb jelly. Yep. So these are really cool because these are bioluminescent and iridescent. And comb jellies live in shallow water environments. In fact, for I think so far most everybody on the channel on the stream, probably like the beaches that you guys go to as far as vacationing go, like you'll probably see comb jellies, or you're probably swimming with comb jellies, and they're so transparent that they're really hard to spot. But if you're out at night and you bump into them, they actually glow blue. And then if you kind of catch them in the right light, they have these beautiful rainbow color. And they're very common in North America. So they actually are all along the coast. Ooh, this is beautiful. What is this? A panda bear sea angel. This looks like a sea slug. I'm not 100% sure, but that looks like a kind of sea slug. But it's really beautiful. And just love the chimera's nose. Yeah, chimeras are so cool because like they look like a cross between like a shark and like a bony fish. They are oh yeah, quackers, hopefully not directly into them. So actually, fun fact, comb jellies do not sting. So that's part of why they're called comb jellies, is they don't have the stinging cells like other jellyfish. Oh, this is crazy. The barrel eye. Comb jellies actually have sticky cells. So if you bump into one, you're perfectly fine. You can actually like touch them and handle them because they just have the sticky cells. So they don't have the same mechanism as true jellyfish, like sea nettles or there we go, sea nettles or I'm trying to think, moon jellies are pretty common. Lion's manes are pretty common. So. But yeah, so that was a really cool shot. This is MBARI, the Monterey Bay Aquarium Research Institute. So a lot of cool deep sea footage from them. So now for our species, the dwarf lanternshark, Etmopterus perryi, we don't have footage of that particular species. We do have footage of other lanternsharks. So we'll take a look at a couple clips. Some of these we might have seen already. So this is the velvet belly lanternshark. And it's a species in the same genus, so you can kind of get an idea of like how these sharks move. You can also see, it's a little hard to tell, but you can also see that beautiful like dark line on the belly. And we'll slow that down for a better view. Here we go. So there's a dark line on the belly, and that is part of its camouflage. Where that dark marking, it's kind of part of like the backdrop. Where if something is looking up at the shark, they're looking at something that. Well, actually, no, sorry. It's part of the backdrop for the. I got that confused. It's part of the backdrop for the bioluminescent organs. So that like dark patch actually has bioluminescent organs that will glow blue. When the shark wants to produce bioluminescence. So hence the name lantern shark. So these species are. It's a really cool collection of sharks that are able to glow in the dark. And also just like a reminder of like just how just diverse and like. I don't know how to say it, like how just like diverse and unique so many different shark groups are. I mean, there are some shark species that change color. Like some of the smoothhounds change color. I'm reading a lot about hammerheads lately, just because just for funsies, and how hammerheads like amplify their electromagnetic sense with the big cephalofoil. The sharks that lay eggs, or sharks that give live birth. There's sharks that can emit fluorescence or use fluorescence in a way to navigate the reef environment or camouflage better in a fluorescent coral reef. So I guess to say it's just like a myriad of abilities that sharks have. That's what I'm trying to say. Is like, it's really incredible to like see like how surprising sharks are, and how like it's not just this one thing. It's just like this incredible collection of different abilities and just different adaptations that have evolved in like a really glorious way. And I think bioluminescence is one of the most like exciting, as far as like it's cool to think that there's an animal that produces light, you know. And in terrestrial environments, we don't really see that much, because the closest that we have is like lightning bugs, you know, which are really cool in their own right. But you know, lantern sharks, you know, kind of share this ability with a lot of other deep sea animals. And we'll take a look at bioluminescence in a second, but it's just like a really cool ability. So. Observations about this shark: it's a very cylindrical body, so lots of movement kind of in the rear half of the body, so that tail is doing a lot of work, because the front half of the body is very cigar shaped. The dorsal fins and the pectoral fins are very small. It's kind of cool to see that the tail is actually quite square looking, or squared off. Like the lobes of the upper and lower caudal fins are pretty squarish. The second dorsal fin is also pretty large, and in fact larger than the first dorsal fin, so that's kind of cool to see. Like all squall forms, this shark species does not have an anal fin, so it's just the two dorsal fins, pelvic fins, pectoral fins, and caudal fin. One more shot of this shark, just swimming alone in the darkness, looking for prey. One thing that's really kind of cool as a reminder is that, so the dwarf lanternshark is the smallest shark in the world, or one of the smallest sharks in the world. But even so, when you compare that to all these other animals in the ocean, it's still kind of a large creature. And I'm talking like if you compare it to like crabs, copepods, plankton, jellyfish, like bony fishes. The smallest bony fish is probably like inches big, you know, but the smallest shark is, you know, like 8 inches. But that's as far as like fish go, that's actually comparatively, you know, not remarkably small. It's not really diminutive. So it's kind of cool as a reminder that sharks are either like mesopredators, like they're kind of like, you know, they're either like in the middle or the top of the food chain, just even based on size. You know, they're kind of like even the smallest shark is in a pretty good position in the food web. So here's another kind of lantern shark. This clip you can kind of see that cute little snout. And this is a different species, but you could still see some cool features, like how this is a little bit of a weaker swimmer, where you see that the current is going to the right of the screen, and the shark is swimming ahead, but he's, you know, being caught in the current. This larger individual is starting to go against the current. You can see, like, again, the squared off caudal fins. The second dorsal fin for this species is about the same size as the first one. There's some beautiful blue margins on the rear half of the two dorsal fins, as well as a little bit on the pectoral fins. Relative to body size, the eyes are pretty large, which makes sense. So this kind of shark is trying to maximize, you know, sight in a very dark world. So it still has use for its eyes. Some species in the twilight zone, you know, if it's like perpetual darkness, they don't really need their eyes, and so the eyes evolve kind of out, where they're eventually like not part of the body plan. But for lantern sharks, they still have use of their eyes and they still need them, so the eyes are quite a bit bigger to maximize light absorption, to see if they can get even the tiniest sliver of light, especially when they go up to the surface for something called deal migrations, where deepwater animals come up to the surface at night following their prey items. So, right, one more clip of this species, and then we'll take a look at bioluminescence in general. But he's very cute. And it's really cool to see that a lot of lantern sharks are actually doing really well. And it's kind of cool to say that, like, right now, even as we're talking on the stream, you know, we live in a world where there's a lot of lantern sharks just swimming around tonight and, you know, having, you know, kind of a good time. So away from a lot of human interaction. So, oh my gosh. But catching up with the comments, Howard, yes, deep sea life is amazing. It looks like a snowy backdrop. That's an excellent comment because that is actually marine snow. So that is an extremely important part of the deep sea environment. We'll go back to the lantern shark to kind of show that. Hold on. Let's go back here. There we go. Yeah, that's actually a good shot of that. Okay, so all of these specks, all of these particles are what's called marine snow, and it's extremely important for the ecosystem of the deep sea, where this is basically, it's kind of like, the best equivalent is like dust in your house. Like when there's things in the environment that break down, so this is like a mix of like, you know, like if say there's a great white shark at the surface biting into whale flesh, and then like pieces of that whale fall off, it will start to sink down, it will start to further disintegrate. If a fish is swimming and the scale falls off, it will start to sink down and disintegrate. Just like any kind of biomatter that starts to kind of sink and it's not really consumed. Or like fish, like even like a better analogy is like fish flakes. Like if you have like fish in an aquarium and you give them like fish flakes and the flakes start to sink down, like the total of all that stuff continues to fall down from the surface level down into the deep darkness, and it accumulates on the seafloor as this pretty like important ooze that a lot of like benthic animals eat and consume, or bacteria harness as far as like kind of producing what they need to produce. But marine snow is also like a really important food source for a lot of midwater smaller fishes. So like fish that, like butterfly fish is not a good example because it's a tropical shallow water species, but fish that are not big enough to eat other fishes, but like are still able to kind of like snip up parts of the marine environment. Or actually a better example is zooplankton, like copepods. Copepods will collect the marine snow and it's a food source for them. And in turn, copepods are eaten by other fish, and then in turn, those other fish are eaten by the sharks, like these little lantern sharks. So, what's actually really cool, and thank you again for your comment, Howard, because like you caught something I actually missed in this clip. Like this is actually the food web in action, where this marine snow, this detritus, it's being collected by, there's brittle stars in the background here, they're eating it. There's going to be copepods in a water column that are going to eat it, and then other predators like somewhat larger fishes will eat the copepods, and then the sharks eventually will eat the fish. So this snowy landscape, even though it's kind of like, there's a part of it that seems kind of gross as far as like it's just bits and pieces of things from the surface, it's vital for the deep water environment, because this is one of the few food sources that the deep water environment gets. Or it's actually, I guess it's a better way to say it, it's the primary food source, or one of the primary food sources, or one of the most important pillars of how the whole deep sea ecosystem functions. So that's a really, really great comment, Howard. I'm actually going to star that. So thank you for bringing that up, because it looks really cool, and it's also a really important part of this, mysterious deep sea environment. So, oh man. Let me go ahead and star that because that's fantastic. Oh, there we go. Sorry. Sorry, I didn't even notice that comment. The tries from above looks so rich, it makes me wonder how close shore the footage is. Yes, so that's a good question. It could be, depending on, let's see where this is actually. Antarctica, deep sea dwellers. So this is Aus Antarctic Science TV. So I'm not as familiar with Antarctic geography, but if it's an environment that's kind of like the west coast of the United States, where you have these shallow water environments and then this really steep drop off, it's probably really easy to kind of, it's easy for like shallow water shelf areas to fall into or tumble into the abyss, where in the east coast of the United States, it's kind of more of like a flat, sandy environment with a gradient, a gradual drop off. The analogy still kind of works, because I know that the drop off that we have off of Virginia is actually a pretty biologically productive area. because yeah, I'm actually thinking out loud now because that's a really good point. Because I think as long as you're near a continental shelf, whether that shelf is near shallow water or away from shallow water, the physics of the shelf allow for this phenomenon called upwelling, where water currents will collide into the shelf and push nutrients upward. So it pushes water upward, and then it carries a lot of nutrients upward. Those nutrients enrich the plankton that are around the shelf area. So when you get to like the top of the surface where you have the ability to harness sunlight, phytoplankton have that dream combo of a lot of sunlight and a lot of sunlight from above and a lot of nutrients from below, and they start like growing like crazy. And then in turn, the zooplankton eats the phytoplankton, and then in turn a lot of fishes congregate in that area, and then in turn a lot of large animals like sharks and dolphins congregate in shelf areas. So shelf areas usually correlate with like really important upwelling areas, and you know, when you have all that activity, say you have like a mass predation event, like a boiling sea of fishes being predated upon by dolphins and sharks, those predators will like rip apart shoals of fishes, and then all that material falls back down into the deep water environment as the marine snow. So it kind of like is this really cool cycle of nutrients coming up, and then detritus falling down. So to your point, Howard, it could be close to the coast. It also could be close to a shelf area where just like, even if it's like not shallow water, if it's a shelf, like the continental shelf, the physics of that can create an upwelling environment, which can in turn create a really productive ecosystem. And the cycle continues. So super cool, super cool. Oh yeah, I love the music hyping the Sharky up. Yeah, this is Subnautica, one of my favorite marine soundtracks. So let's see. Minja's true. I wonder if there's a reason for them not shrinking to the same extent. I'm still assuming the smaller prey equals need for a smaller body and a predator, but then again, sharks are full of surprises. That's a really good point, because the deep sea environment is fascinating, where we have a lot of small sharks, like lantern sharks, but we also have like the really big sharks, like the six-gill sharks, the sleeper sharks. Those are huge deep water predators. So, oh my gosh. I love these comments about the music. Oh my gosh, yeah. Oh man, you guys are awesome. I'm seeing. I missed a lot of these comments about the detritus, so that's awesome. So, oh Howard, I've heard of upwelling, particularly in cold water environments. Yes, so that's actually it's really cool. With cold water environments, you have a lot of that. Like in temperate environments, you have those changes in temperature that really help upwelling dynamics. So, like at the surface level, you have when you in the northern hemisphere, when you have the summer, I mean I guess both hemispheres, but when you have the summer warming the surface level, a lot of the heavier colder water sinks below the warm water. Then when you have the winter, when the surface water starts to decrease in temperature, the cold water rises. So it's just like what's happening on the surface is actually echoing in deep water environments. And I know we've been talking about like deep water environments are very stable, and they are for the most part. Like that's part of why a lot of deep sea shark species are cosmopolitan, like they're found all over the world, because like when you get super far down in the deep water environment, you do have a pretty consistent temperature and a consistent pressure, so that in that sense, you can have a lot of animals migrating across that environment. However, if you are in a deep water environment and the layers above you are seasonal, like very seasonal, that's going to affect their productivity, and that is going to indirectly affect the amount of marine snow or other phenomenon happening, like upwelling phenomenon. So it's really cool. It's really complex, and it's a lot of fun to kind of think about. So, oh my gosh. Oh, interesting, Quackers. What kind of shark is it? Oh, this is so cool. Oh, it's a dichotomous key. That's awesome. Those are the coolest thing. I love dichotomous keys. They're super, super cool. It's kind of like, the best analogy is like, it's like a choose your own adventure, where you have two choices. Like, do you go into the house, or do you go to like the village or something like that? So they're super fun. Interesting. Oh my gosh. That's really cool. Yeah, I would love it. That is so cool. So dogfish shark. It might be a piked dogfish, and it could be yeah, because like so that actually this could be a piked dogfish. So actually, quackers. Let's see if the shark. Hold on. A piked dogfish, aka spiny dogfish. Sorry, I'm typing a comment. If the shark has a shark. Okay. So that's actually really cool. So I'm just left a comment. So quackers, for the shark that is preserved, if it lacks an anal fin, it is probably a pike dogfish. This is also known as a spiny dogfish. It has white spots and it also has the spines on the dorsal fins. And the reason I say that is I think today they're transitioning, for shark dissection and shark biology, they're transitioning from the dogfish to sharp-nosed sharks because the dogfish are they're vulnerable species and their life history is they grow very slowly, reproduce really they grow extremely slowly and reproduce kind of infrequently. So I think as we've started to realize that, we've been transitioning to sharp-nosed sharks, which grow really quickly. So if it does not have an anal fin, it's probably a pike dogfish. If it does have an anal fin, it's probably an Atlantic sharp-nosed shark. So yeah, I'd love to see. Yeah, let me know your observations. Tell me if you don't mind. Tell me what you can see as far as the shark that you have, because I'm very curious what it is. My bet it's probably one of those two species, because those are pretty popular in shark biology and shark dissection. And if it's a dogfish, it's probably an older specimen, which is kind of cool. And then if it's a sharp-nosed shark, it's possibly a newer specimen. So, but our last clip, while we're checking that out, this is a clip on bioluminescence, so the ability to create light underwater. And there's a dude who is not bioluminescent. Okay, there we go. So it's really cool to see how this works. Oh, and this is great that they're showing this. So you can see bioluminescence in shallow water. Isn't this incredible? So let me go back. Oh, they also show fireflies. Sorry, that was a lot happening at once. So I'll go back and kind of narrate. So here is a deep water jellyfish. Here, and I'm gonna guess this might be Puerto Rico. Puerto Rico is a very famous bioluminescent location, but here, these are bioluminescent plankton. I believe they're diatoms, but when something touches them or kind of like bumps into them, they will emit their bioluminescent light. So here you can see it where the waves and the water breaking, that's kind of rattling them and disrupting them, and that is triggering the bioluminescent light. So this beautiful wave of diatoms or plankton. Again, I think this is Puerto Rico, but this can happen in a lot of different places in the world. And they also show fireflies, so bioluminescent there, but we'll go back to this really cool shot of just walking in bioluminescent sand. Isn't this amazing? Also, this is my favorite thing, by the way. Like, if anybody's like a fan of the movie Avatar, like the blue alien Avatar, it's like we actually live in that world. And James Cameron, who loves the ocean, like he based a lot of Avatar on marine environments, and this is one of those things. Like Avatar being so psychedelic and colorful and trippy, like you can experience that. It does exist in this world, which is so cool to see. Even in North America, those comb jellies I was mentioning earlier, I mean, they're pretty common. So if you go out at night, and I would say in the summer in North America, if you go out at night in the summer, in the North American summer, you should be able to kind of like, and be careful, but like you should be able to maybe like walk in the water, kind of like, you know, maybe even if you go fishing or like, or actually probably what's better is like maybe kind of like a net, like a collection net. You should be able to kind of bump into a comb jelly, and you should be able to kind of elicit that bioluminescent response. So, and I'm speaking from experience. In Virginia, we have the lady's comb jelly, and then the sea walnut, also known as a sea gooseberry. And we used to do plankton trawls, and when we haul the nets from the water, this beautiful electric blue would like glow. And it's really cool. Like that's Virginia. That's like, you know, a classic mid-Atlantic state. It's not famous for bioluminescence like, you know, Puerto Rico is, but it happens here. So, and that species of comb jelly, that's pretty common all along the coast. So if you live in North America, you can experience bioluminescence in some of the local beaches. So it's really cool, and at night especially. So. But so as far as I know, it has to be summertime, because that's the only time that the comb jellies come out. So, but yeah, this is kind of cool showing. Oh, this is so cool. This is a really cool highlight of just bioluminescence and how it functions in the deep sea environment. And some of it is like communication. Some of it is predator evasion. Some of it actually can be predation itself, like lures, like an anglerfish. So I shouldn't knock this guy because he is part of MBARI. So that's the same group that we were seeing earlier, Monterey Bay. So man, it's so beautiful, isn't it? Such a cool thing. I think if I'm seeing this correctly, this is, this might be, there are some shrimp that actually can shoot bioluminescent, or not shrimp, I forget what kind of invertebrate this is, but there's some invertebrates that can shoot bioluminescent fluid as a way to kind of like, it's like a smoke screen, it's a way to avoid predators. Predators will be drawn to the light, and the prey item can get away. Man, here's an anglerfish using bioluminescence to attract prey. I doubt we'll see the lantern shark. I hope we do, but it's kind of hard to get bioluminescent footage of sharks themselves. So. That's so cool. This is bell of a jellyfish. It's so gorgeous. Also, music is fitting perfectly. And it's cool you can see it in the background here. So. For lantern sharks, I believe all species have the bioluminescence on their bellies. So it's in the ventral part of their bodies. I don't think any lantern shark, or any dogfish for that matter, has dorsal bioluminescence. I think it's all in the lower belly. And I believe that is all for camouflage, or mostly for camouflage. There was this really cool article that we saw on the stream. I think this was for the pocket shark. But most of the bioluminescence in sharks is for camouflage, but there's some of it that could be used for mating communication, and then some of it could be used for predation. And I believe it was pocket shark. It emits bioluminescent fluid, and I think that could be a way to attract mates. So, but yeah, it's an amazing phenomenon. So. All right. Okay. So we'll exit out of here and start diving into our shark specifically. So, oh my gosh. Oh, Howard, we just dissected dogfish in high school. Same here, and it was the pike dogfish. So, oh my gosh. Love cuttlefish, so hypnotic. Yes, yes. I love like deep sea drones. I think that'd be the coolest thing ever. I would love because you know how we have BRUVS, the baited underwater video surveys. There are some deep sea versions of that already, but I would love it would be so cool to have kind of like a deep sea constant feed. We saw. There's a pier in Florida that has a constant feed. I think there's a place in North Carolina too that has a constant feed of, you can see it's like a live cam of sharks and just all these other different fishes. But one day it would be so cool to do like a deep sea feed. So, oh hey Howard, good point. I've seen some along the lateral line and in the spines. So bioluminescent spines, bioluminescent lateral line. Very good point. So. And thank you. I forgot that was actually part of some lantern sharks. So as far as where you can find bioluminescence, so I think with that we'll dive in to lantern sharks in general and kind of make our way to the dwarf lantern shark, Etmopterus perryi, arguably the smallest shark in the world. So it's kind of cool to see a superlative in that way. So here we go. Etmopteridae, the lantern sharks, also known as the black dogfishes. There's small sharks with cylindrical or slightly compressed bodies. We'll just read out the key characteristics, which are in bold. Head with 5 gill slits, all anterior to the pectoral fins. Spiracles always present, large and just behind the eyes, so right there. Eyes on the side of the head without nictitating eyelids. 2 dorsal fins with a strong grooved spine present. So we have a spine here, and then a very large spine in the second dorsal fin. The first dorsal fin is usually smaller than the second. Strong grooved spine present on both dorsal fins. You got the spiracles. There's no anal fin, and usually luminescent organs on the abdomen. Let's see. Color: body and fins grayish to blackish brown, usually with conspicuous black marks and luminescent organs on abdomen, over pelvic fin bases, on caudal peduncle, and on caudal fin bases. So here we go. So lantern sharks mostly occur in deep water near the bottom on the continental and insular slopes between 200 to at least 2,213 meters. So that is the twilight to the midnight zone. Some species venture onto the continental shelves up to 70 meters, so the sunlit zone, and a few species are oceanic, ranging far from land. Circumglobal in most seas and range from the tropics to high latitudes up to Iceland in the North Atlantic. Some of the species form large schools and can be among the most abundant deep-water sharks in limited areas. Feeds on small bony fishes, cephalopods, crustaceans, and tunicates. Reproduction is ovoviviparous with 6 to 20 young per litter. In the Far East and the Eastern Atlantic, these sharks are commonly fished with line gear and bottom trawls for human consumption for their livers, which are extremely large, oily, and have a high squalene content. They may be caught as bycatch in other fisheries, but are not known to be utilized. Here we go. So, similar families occurring in the area. So we have other squaliform families, except for Echinorynidae. Echinorynidae recently was reclassified into an entirely new order, Echinoryniforms. So these are the bramble sharks. You have Squalidae. Which are the classic dogfishes. So the difference between lantern sharks and dogfishes, it looks like lantern sharks have grooved dorsal spines and the dogfish don't. And then the dogfish also have precaudal keels and pits. Kind of like a more distinctive anatomy as far as the caudal fin area goes. Lantern sharks have a smooth caudal fin and the grooved spines. So there we go. Let's see. Centrophoridae, the gulper sharks. It looks like the first dorsal fin is larger than the second, or equal. Lantern sharks have the first dorsal fin smaller than the second. Somniosidae, the sleeper sharks. Looks like sleeper sharks have lateral keels and either have small dorsal spines or no dorsal spines. Sleeper sharks are really easy to tell apart from lantern sharks. They're also usually a lot larger. So, Delacidae, kitefin sharks. Looks like spines present only on first dorsal fin or absent entirely. Whereas, again, the lantern sharks do have spines, so they have spines on both dorsal fins. Oxynotidae, the rough sharks, these are the cute pyramids who they have just a triangular shape. Dorsal fins high and angular, so they have the enormous dorsal fins. They also have huge areas of flesh kind of protecting the spines, so they're very, very strange anatomy, very easy to tell apart from lantern sharks. I'm not even going to mention these two, the saw sharks and angel sharks, because they're very easy to tell apart. Here we go. So here, we were talking about dichotomous Quackers was mentioning the dichotomous keys earlier. So here is a dichotomous key to identify lantern sharks. So we'll kind of play around with this a little bit to get to our species. So here we go. When you look at the two choices, our shark has upper and lower teeth dissimilar, with a slender center cusp on one or more cusplets on each side of the upper jaw and compressed and blade-like in the lower jaw. Okay. So they're referring to right here where you have the upper teeth are these like little spiky teeth, but the lower teeth are kind of like this locked like chainsaw kind of tooth situation. So if this is the arrangement, this is Etmopterus, which is the lantern sharks. We're reading step 1, we go to step 2. Step 2, we know that it's not this one, so our shark's head and snout is flattened, considerably wider than deep at eyes, body either uniform dark above or below or abruptly darker on undersurface, photophores concentrated in darker areas on the sides and lower surface. So number 3, our shark has dermal denticles on sides of body cuspidate. Let's see. Oh, I see. So it has dermal denticles like this figure right here. So it has kind of like high, almost like toothy looking dermal denticles, like kind of curved, really spiky looking denticles. Interesting. So we'll go step 4. Dermal denticles on sides irregularly situated, not in rows. So we'll go to step 5. And I'm kind of cheating because I know we're looking for Etmopterus perryi. Just going to keep going until we find it. So underside of snout covered with denticles. Okay, so we got his snout has denticles. We know it's not these two. So the color lighter above with prominent black markings below. First dorsal fin spine with about opposite to pectoral fin rear tips. So it's step 8. Oh man. Suprapelvic black marking, continuous interior, posterior, and ventral patches, continuous size smaller, adults below 300 millimeters long, or 30 centimeters. So very, very small. And finally, here we go. Number 9B. No mid-dorsal band on white, size smaller, adults about 160 to 212 millimeters long, figure 10. So this really convoluted key brings us to this species, Etmopterus perryi, the dwarf lantern shark. So I know it's kind of like a mouthful, kind of like reading all of that, but it's a good example of like how to use a dichotomous key as far as you have to look for these really tiny features, these really minute features to tell two species apart. So it's kind of cool to see the big ones where the dark belly, the patterning of the dark belly, the dorsal spine, so you have the small one in the front and then the huge one in the back. The shape of the dermal denticles are very thorny and they're irregular. You can actually kind of see that here where you have like this dense coating up here, but then you have this kind of like lighter patch over here. I think based on this illustration, this is referring to the size of the denticles. So this is the dwarf lantern shark, Etmopterus perryi. I think there's a species profile on this too, so we'll kind of keep reading to get to that. There we go, yeah. Okay, dwarf lantern shark, maximum size about 21 centimeters, so little guy. Occurs on upper continental slopes at depths of 283 to 375 meters, so this is a twilight zone species. Biology, little known. Of no interest to fisheries, only known from Area 31, so they're referring to, I think this is an FAO guide, or a similar identification guide, focusing on a specific area which looks like the Caribbean. It's only known from Colombia, so off the Caribbean coast of Colombia. Interesting. So So let's see what else we could find. Here is a preserved specimen of dwarf lanternshark. Again, note the enormous second dorsal spine. Really large eyes too, but very small. So this is a really good size comparison. This actually might be close to an adult. Yeah, an adult species, or adult specimen. The smallest shark. Oh, okay. This is claiming it is the smallest shark. The smallest shark, a dwarf lantern shark, Etmopterus perryi, is smaller than the human hand. It's rarely seen and little is known about it, having only been observed a few times off the northern tip of South America at depths between 283 to 439 meters. The specimen pictured here was discovered in the Caribbean Sea off the coast of Colombia in 1985 at a depth of 290 meters. Like other lantern sharks, the dwarf lantern shark has light-emitting organs called photophores along its belly and fins. These help them camouflage when they feed in shallower water. The lit-up belly blends in with the sunlight streaming down from above. In darker water, the light attracts smaller animals, which the shark preys upon. It also has big eyes for a shark to help it see in the mostly dark waters of the ocean's twilight zone. Okay. I am curious. I'm so sorry, but I'm curious about this lightsaber thing. So let's watch a short video from Noah on lantern sharks. I just want to see if this is anything new. I don't think I've ever done this before. A QuickTime video. Can we do that? Oh, looks like we can. I'm gonna catch up on the comments. Oh, Howard, so the dogfish spines are smooth and round? Yes, it looks like it. So, oh, where's my QuickTime thing? That kind of reminds me, I see there's this meme going around about the QuickTime event, like missing the QuickTime event, so...
It's an Etmopterus shark, also known as a...
Oh. Can I move that? Alright. Here. Okay, I'm glad we clicked on this. So this is a good view. I'm trying to get this thing out of here so you can actually see the lantern shark moving. So this is so cool. Really glad we clicked on this. This is a really good view of another living lantern shark that you couldn't find on YouTube. So thank you, Noah. And also look at this. Look how iridescent it is. Howard made a comment earlier that it has kind of like a velvet look, or like kind of like a purplish hue. And you can actually see that really clearly here. So that is so cool. North Atlantic Ocean. So this is not our species. It's a different kind of lantern shark. But it's still a really great showcase of like just how beautiful these sharks are. And like, look how reflective the scales are in the light. So it's actually really cool. I've been talking about how comb jellies have both bioluminescence and iridescence. Iridescence meaning reflecting light in a really beautiful way. This lantern shark is no exception. It has bioluminescence, but also has this beautiful purple sheen on its back. So, man, that is awesome. We'll take one more look. Actually, wait, where is this? Sandy Tongue, Georgia. Okay, so this is off. I can't read that, but I can see that that's Georgia, South Carolina. So this is off the coast of South Carolina. Interesting. So, all right. Oh yeah, South Carolina Department of Natural Resources. I just saw that. Man, so glad we clicked on that. That's a really good shot of a living lantern shark in its natural habitat. That's extremely cool to see. Man, this has been a fun deep sea episode, because it's like we've covered a lot of deep sea sharks, but I think this one really gets the deep sea vibe, and I'm really enjoying it. So this is so cool. All right, let's take a look at the lantern shark lightsabers, because I'm watching the Acolyte. The season finale is tomorrow. It's okay. it's okay. It's not great, but sorry, I don't mean to rag on it. It's just it's a mixed bag, and I can't find this lightsaber article. So, but if you like Star Wars, I would recommend the Acolyte just because it's a lot to chew over. I know it's getting a lot of controversy, but it's like you know, it's interesting stuff to chew over. As a show, if you like good TV, I probably wouldn't recommend it because it's a little frustrating to watch. The writing is a little mixed, so sorry. overall, I think that's praise because I think it's getting disproportionate negative reviews for what it actually is. It's okay. It's oh well. That's my half endorsement of the Acolyte. It's not really an endorsement, but anyway. This lightsaber article didn't come up, so I think we'll keep moving for Lanternshark. So, but I'm really glad that they showed that clip of the species. So, yeah. Oh, I love these comments. He looks so shiny. Goes blub blub bling bling. Oh my gosh, so cool. Let's see. Etmopterus perryi, dwarf lanternshark. Biology: body strongly marked with light and dark areas, streaks, and spots. Very small, probably the smallest shark, with a somewhat flattened head and snout. Its depth two-thirds or less than its width. Moderately large eyes, slender needle-shaped tentacles. The needle-shaped tentacles are so interesting to me, where it's like I wonder why that is. In random dense array, fins moderately large. Let me guys know in the comments if you know why lantern sharks have needle-shaped tentacles. My first reaction is this like a predator deterrent? Like, is this kind of working like a porcupine fish, where maybe it deters predators? I don't know, because it's like based on the few photographs that we've seen of lantern sharks in life, I mean, they're not very prominent, so probably wouldn't work. Yeah, this drawing by Mark Dando. Mark Dando is an excellent shark artist. Yeah, these thorny tentacles, I guess they're too small. Plus, you have the two spines, which would be a natural predator deterrent anyway. So, I'm not sure what the thorny tentacles would do then. But it's so unique because most sharks have like flat tentacles that help reduce drag. So, I don't know if the thorny tentacles might further reduce that or further help counter the effects of drag. So, but this is a beautiful illustration of our species, the dwarf lanternshark. The eye is so interesting because it's huge, and then there's this like little socket area in the interior part of the eye, and I'm not really sure what the function is. And I'm also not really sure if this is maybe a bias drawing as far as like, is this a natural feature of the shark, or is this maybe specimen damage from the few specimens we've seen? It's kind of hard to tell. What's most interesting is seeing where the dark patches are, and these are presumably where the photophores are, but you see dark patches beneath the snout, beneath the eye, and on the upper jaw. You see a white patch on the lower jaw. The chin has a dark patch with a little bit of a cape. You have this beautiful dark belly, and then you have also another cape, like a little like dark cape with the a light area on the pelvic fin. You have this like little dark streak kind of around the pectoral fin, like the origin of the pectoral fins. You have small dark streaks around the spines as well, a dark streak towards the caudal, like the tail, and then these beautiful dark blotches. It's a beautifully colored shark. It's a beautifully marked shark. You know, and also excellent species to do an art project on. Like it's really cool looking. Because it's like there's no other species or other shark that has like a color palette quite like this, so it's really cool to see. Very exquisite. Also, shout out to Sharks for Kids. This website is awesome. I personally love Sharks for Kids a lot. I've met them at least once, I think maybe a couple times, but they're really cool. They're very friendly, and I really love what they do. So it's cool that they have an Elazaring of the month, which is the Dwarf Lanternshark. So we'll take a look at the summary. So, Dwarf Lanternshark is currently the smallest known shark species. Maximum length of 20 centimeters or about 8 inches, and it weighs less than 2 pounds, so very small. Body is dark brown like many deep sea animals, has the ability to glow in the dark. Let's see. Upper jaw contains 25 to 35 rows of multi-cusped dagger-shaped teeth, while the lower jaw holds 30 plus rows of sickle-shaped teeth. Little is known about the dwarf lanternshark. It is a deep-sea species inhabiting the bathypelagic zone. also known as the midnight zone at depths. And actually, this is interesting. This is a little different. We've been seeing other reports of the shark occurring in shallower water, like in the twilight zone, but this is showing deep water, like the midnight zone. So it's been found in the Caribbean Sea off the coast of Venezuela and Colombia, and in the Pacific Ocean near the Hawaiian Islands. Interesting. When was this written? This is, oh, can I leave a heart? Yay! I can. There we go. This was written... website's copyright 2024. Article, was that at the top of the page? This was written in 2020. Okay. So that's actually pretty recent. Let's see. More research is needed to determine the full range. So I wonder if the Pacific Ocean is a new, like Hawaii for the species is a new development. Let's take a peek at IUCN Red List really quick. IUCN Red List does not list this species in Hawaii. It just has it in Colombia and also around here. Is this French Guiana? Do I have this right? No, Venezuela. So Colombia and Venezuela. Gotcha. Here we go. Dwarf Lanternshark feeds on shrimp and small fish. It's theorized that the shark uses its bioluminescence to attract its prey. Interesting. Mother gives birth to 2 to 3 live pups who measure roughly 6 centimeters, 2 inches long. So, wow. Wow! Oh my gosh. Okay, that is actually really tiny. That's really, really tiny. I can't even imagine a shark that small. That's... wow. Okay, this guy is really, really, really tiny. Like, a dwarf lanternshark pup, that is really small. For comparison, that's the size of like a minnow. Or, like, a seahorse is probably 2 or 3 times larger than that. So that's kind of wild to think about. Shark might be killed as bycatch. So this individual in this person's hand is an adult. That's just kind of mind-boggling. It's the world's smallest shark. All right, so we'll take a look at other sources for the dwarf lanternshark. Mingus, weird. Does it have a larger range or is it sort of disputed? I have a feeling, I have a feeling that the Pacific thing might be not correct because, and the only reason is, for the research I was able to find tonight, it is all about kind of Colombian waters, so I don't think there's a lot of information of it in the Pacific. Also, the IUCN Red List is only showing the Colombian range, so it could be that maybe they found a species in Hawaii, and it's either maybe the and I love sharks for kids, maybe the author confused the species of a different kind of lantern shark, or maybe in Hawaii they found a different species of lantern shark. They temporarily classified it as Etmopterus perryi and then maybe split it off as a different species altogether. Because like, let's double check, because IUCN Red List only has it in the Caribbean. Let's double check fish base. I don't know if it's going to show. From this map, it's only showing... This is a little confusing. This is showing a little bit of North America and the Caribbean, and it's giving it a much larger range. I don't know. I would err on the side of IUCN Red List. So, you know. Oh, Howard, that's a spherical. Yes, that is a pretty. Let's go back to the. Where was this illustration? Oh. Yes, that's pretty large. And Mark Dando, he is an excellent shark artist, so that's actually pretty accurate. So, and like I know I was talking about like this. Socket area here, but I do trust Mark Dando. He's an excellent shark artist, and he's very good at what he does. So it is kind of cool to see. Oh, here we go. Etmopterus perryi type specimen. Okay, where was this collected? Colombian Caribbean. These are both from the Colombian Caribbean. So this individual, very large spiracle. It does have the similar color pattern. Yeah, because you can see like the streaks, like the streak here. This is a very damaged individual, but you can still see like the unique black streaks, the cape here. Gotcha. And then this individual, which is kind of wild to see, this looks quite a bit smaller. This might be a smaller individual. Look, but you still see that. You still see the black cape. You see the lighter patch near the pelvic fins. The caudal fin looks slightly different, but that also could be specimen damage. This almost looks a little different to me as a species, but gotcha. Sorry, I'm getting so excited, kind of like looking at these different sources. I'm losing my place, so you have to carefully read the physical description as published. Yes. So definitely agree, Howard. As far as just shark identification, the type specimen is always really important to cross-reference when you find new individuals that you think is maybe the same species. It's always important to cross-reference, and that's also what kind of makes dichotomous keys like the one that we went through extremely useful, because it will identify those key features that separate the species from other kinds of lantern shark. And if there's an individual that doesn't fit into any of the keys, it could be a new species altogether. So, what kind of breeds through fishes of the Western Atlantic? It's a different illustration, but same markings. Especially here, like it's a pretty complex pattern around the pelvic fin. And then you have that. I really like that black streak near the tail. So let's see. We'll just kind of breeze through this. Second dorsal fin being more than twice as large as the first. There's a very specific description. It's talking about like the proportions and how the fins like relate to each other. Let's see. Just scanning to see if there's anything new. Eye green. So in life, this lantern shark has green eyes. Very cool. One of the smallest known sharks. Still a shallow water depth range on the over the upper continental slopes. So I think I love sharks for kids. I think they might have confused this with a different species, because that like Sharks for Kids is the only site that has the deeper depth range, whereas the other ones, especially Fishbase, has a shallower water range. So let's see what IUCN Redless has, because it will have the depth range of species as well. Okay, yeah, it's the same thing, like Twilight Zone. So 189 meters is the upper limit, which is kind of peeking into the Sunlit Zone, and then 598 meters is lower limit. So that's right in the middle of the Twilight Zone. So, okay. Range known only off of Colombia, and the references are Sharks of the World, so Ebert, Dando, and Fowler. So this is the same authors as the book featured, or one of the books featured in our contest. So yeah, I trust them, and yeah, I think I love Sharks for Kids, but I think they got this confused with a different species, because this shark is only known off of Caribbean waters in Colombia. So yeah, so let's see. Common names: Dwarf Lanternshark. This is interesting. Teeth are sexually dimorphic in adults. The males with upper jaw teeth generally with 5 cusps, the male cusp less than twice as long as the next lateral cusp. The females with upper jaw teeth of central part usually with 3 cusps. And teeth generally stronger and heavier than teeth of males. Lower jaw teeth are about as in other species of Etmopterus, so to a slight degree the tips turn up more than larger specimens of Etmopterus or Squalus. This is really cool. So my theory about why they're sexually dimorphic is a lot of shark species, and like see how the biology says distinct pairing with embrace. A lot of shark species, the males will bite the pectoral fins of the females to hold on to them while they insert their clasper into the female's cloaca for mating. So my theory about why the lantern shark's teeth, or the dwarf lantern shark's teeth, are sexually dimorphic, meaning that they're different between the sexes, is that the male shark probably, my guess or hypothesis, I should say a hypothesis, is that the additional cusps help the male have a more secure attachment to the female's pectoral fin as he's mating. So that's my guess in terms of why there's a difference between male and female teeth. Because I can't imagine a difference in diet, because these sharks are so small and they probably occupy a very similar, just trophic niche, like food, like place in the food web. So I don't think there's a real sexual difference between that. So I theorize or hypothesize that that has to do with mating. So the males have more cusps in their teeth for a more secure grip to the female. So that's my guess on that. So, but let me know if you guys have other guesses as far as why the teeth are different between male and female lantern sharks. And then finally, we'll take a look. Quacker's a funny comment. Oh my gosh, nom nom, love me, babe. That's so funny. Thank you, Howard. Love your hypothesis. Thank you. Oh my gosh, love that. Music makes sharks for kids seem like the most epic sight. Yeah, like I love that this is the smallest sharks in the world. One of the, like, arguably the smallest shark in the world, but it's getting this like really badass soundtrack. I really enjoy it because like it deserves it. I mean, all sharks are cool, no matter what size, no matter what niche. They're all cool. They're all actually excellent predators, and the dwarf lantern shark is no exception. So he deserves that badass music as he's going after his shrimp in the Twilight Zone. I mean, honestly, like for real, this species lives in a terrifying environment as far as like perpetual darkness, swimming alone, not knowing if it's going to bump into like a viper fish or a fangtooth or a six-gill shark. Like it's a really impressive animal as far as like just being able to survive that kind of environment with the immense pressures that would crush you or me. Like this shark is doing it, so it's really, really cool. Dwarf Lanternshark, Etmopterus perryi, least concern, so fortunately the species is doing okay. And it makes sense. It's probably removed from a lot of fishing pressure. We'll take a look at why the species is least concern. Dwarf Lanternshark is a small deepwater shark that occurs in the western central Atlantic and is known from off Magdalena and Guajira, Colombia, and Los Testigos Islands, Venezuela. It inhabits the outer continental shelf and slope at depths of 189 to 598 meters. This species is catchable in trawls and may be caught in other gears, but its full distribution is unknown. Where it is known to occur off Caribbean Colombia, there are exploratory fisheries at depths of 200 to 550 meters. Deepwater fisheries at depths of 280 800 meters are operating with little management in various parts of Venezuela, but there is no trawling at those depths. There are no estimates of the population trend, but since it is not suspected that this shark is currently exposed to sustainable fishing pressure at this time, the population is suspected to be stable, and the dwarf lantern shark is assessed as least concern. So, it is a little scary to see some fisheries penetrating into the Twilight Zone. That's one of the biggest fisheries concerns that I think has been raised for a while, is this idea of we're kind of exploiting a lot of and this is kind of more of like a catch-all, because there are some fisheries that are sustainably managed as far as I guess a good example, I talked about it recently, but like Chesapeake Bay striped bass, that population was crashing, and then fisheries management brought it back to sustainable levels. It's also known as rockfish in the Bay Area, but so there's some shallow water environments that are actually, they do have sustainable fishing. There's a lot that don't. There's a lot that have terrible fishing practices, and there's a fear that once you exploit shallow water environments, you increase the technology to plunge into deeper environments and start harvesting deep water areas. And I've talked about orange roughy before, but that was a big deep water species that was plummeting due to deep water fishing. And fortunately, there's been awareness raised about that species. I believe orange roughy is off the menu, at least in the United States. It's not really... I mean, like, some parts might still have it, but it's not popular because it is a poster child fish of like, yeah, that species is not doing well and you really should leave it alone. But anyway, there is a real fear of deep water fishing because deep water animals grow more slowly, reproduce more slowly. They can't sustain the fishery's impact the way shallow water animals can, because a lot of shallow water animals like can grow pretty rapidly and reproduce kind of rapidly. So there's a fear about deep water fishing. Fortunately, I really appreciate that there's least concern about this species, where it seems like it just doesn't really make up a big part of the catch. And honestly, the shark is so small, it probably evades at least some deep water gear. So I think that least concern is well deserved. A lot of lantern sharks are least concerned because they're just kind of like out of harm's way for the most part. So, but just as a reminder, deep water fishing is kind of scary. It is something to be mindful of like, yeah, that can have a really potentially negative, or actually not potentially, it can have a very negative conservation impact. So just going to scan for more notes. We probably don't have a lot though because it is not a well-known species. So I think we'll probably hop over to research. There's a couple of articles on deep water biodiversity and lantern sharks in general. So we'll kind of take a look at that. It's not quite 10:30 yet, but it's probably a good time before we dive into actual science, or like actual like deeper science, to think about next week's shark. So if you have a shark for next week, this is also the stream that is going to be the contest announcement. Please leave a comment in the chat on what species you'd like to review. So, let's see. I love that, Howard. Surrounded by monsters. So, Mingus, it feels like exploiting the environment we haven't even fully explored yet. Yeah, it's so freaky. Like, there's that common phrase that we know more about the moon than the deep ocean, and it's true because like the moon has no life on it, and you can kind of like, because it's not biologically productive, like there's nothing there. I would imagine the chemistry on the moon, or kind of like the physics of the moon, is kind of more simple than deep water environments. So it sounds kind of wild that we know more about the moon than the ocean, but when you think about it, the ocean in a lot of ways, or the deep ocean in a lot of ways, is a lot more difficult to access, just because of like the actual physics of going into those high pressure areas and how you coordinate that, as far as like how do you access those areas. Like, what's your launch point? When you think about like the Southern Ocean, like around Antarctica, how do you get to some of the open ocean deep water environments from where? Like, where do you start? Do you start from New Zealand? Do you start from South America, like Argentina? Do you start from Antarctica itself to get to like that midpoint that's like completely inaccessible? It's just kind of wild. I mean, it's not completely inaccessible, but it's extremely difficult logistically to get into those environments. So yeah, it is sad in a lot of ways to think about we're ruining environments we haven't even learned about yet. I will just kind of emphasize there is a lot of hopefulness. Just the scope of deep sea environments is so enormous that I think like overall they're going to outlast human impact. And I think we talked about this before, so I won't spend too much time on this, but I think today there's just so much more across like a lot of countries. Like, there's so much more self-awareness about green practices and just environmentalism, and it's really affecting things. Also, on top of that, I mean, there's a lot of metrics about like population growth coming to an asymptote, at least in like Western countries, or Japan. Japan is actually experiencing population decrease. So there's a lot of things happening that it's like, I feel like we'll get to a point where sustainability is possible in the future. So we'll see as it plays out. But deepwater environments are just so structurally complex that there's a lot of like hope. I feel very hopeful about them being like resisting a lot of human interference or a lot of human impact in the long run. One more thing kind of related to deepwater environments, there's a fascinating theory about carbon sink, where we've been talking about global warming and how it's negatively impacting the world, and a huge contributor is music rave mode. Yeah, a huge contributor is human release of greenhouse gases. So human harvesting of like fossil fuels and burning those fuels, and how it works. Like bringing those fuels and all of that gas going into the air, like carbon dioxide. There's this interesting thing with the deep water environment where a large portion of carbon dioxide is falling back into deep sea environments, and scientists aren't exactly sure. At least this is what I like. One of my professors, early 2010s, was telling me about this. That like there's this weird mechanism where the deep water environment is trapping carbon, and scientists aren't exactly sure what's causing that. Whether that's bacteria somehow like capturing it, or some other organisms in the open ocean capturing it. But the open ocean and the deep water environment is a carbon sink. So it is recapturing some of the carbon that we're releasing in the atmosphere, which is really cool and very helpful. It's really nice to see that like, it's not just us. And I'm saying this because like, conservation, again, it can be a very depressing field. A lot of people are really, terrified of it. Just because like when you learn about human impacts, and they are very devastating, it just feels like we just keep ruining things and nothing changes. But what's interesting is that the dynamics are a little bit more complicated than that, where we are releasing carbon into the atmosphere, but there are some parts of the world that are capturing it. This is why rainforests are really important, because that's actually a natural carbon trap, or like not trap, but like a carbon capture thing, like because like trees take up carbon dioxide and produce oxygen. So rainforests are really important because they capture carbon. All forests are important because they capture carbon. But open ocean and deep water environments are really important because they do that too. And scientists aren't exactly sure why that is. Like, we don't know. Is it phytoplankton? Is it just the abundance of phytoplankton capturing carbon? Is it something else going on, like bacteria somehow having an effect on that? So it's really cool to see that there's things at play that are. It's not just us ruining the world. It's also like there's some dynamics happening in the natural world that kind of help things out a little bit. So, which is cool. It's really cool to see that. So I just want to catch up on the comments. If you compare moon physics to marine biology, the entire ocean is much harder to access than the moon, which is crazy considering the moon is literally in space. Yes, absolutely. Because at least like in the moon, like getting to the moon, you have to like break through the atmosphere, and then you are in this stable, predictable environment, I imagine, once you break through the atmosphere. As far as like the moon has its own gravity, but it doesn't have, and correct me if I'm wrong, because I'm not really that familiar with like space physics stuff, but like the moon has its own gravity, but it doesn't have an atmosphere. And so it's like you're there and you can walk on it, and there's no oceans to dive in. There's no like, you're just walking on it, you can collect samples, like it has these mountains and valleys, but there's no life. There's no also, does anybody remember that crazy horror movie Apollo 18? Like, there's no life unless you watched Apollo 18. So like Howard, global warming is a common theme throughout prehistory. Yes, so part of global warming, yes, the environment is stable, but a lot can go wrong for attack. Yes, both are correct. So part of global warming is that there is a part of it that is a natural, like Earth cycle where, and I know this is a very popular talking point for opponents of climate policy, because it is true that there is a natural Earth cycle where the planet is naturally warming. The Earth oscillates between cold periods and warm periods for a variety of reasons. We had the Ice Age, which was a cold period. Now we're entering into warm period. So in prehistory, yes, global warming has existed. On top of that, there has been human impacted global warming in prehistory as well, as far as human settlements burning fires or I guess you can't say clearing forests, because that would be like agriculture, and that would be the beginning of history. But to Quacker's point, yes, the technology that we developed, especially in the industrial era, has accelerated that to an insane degree. So the counter argument for those who oppose climate policy and use that natural cycle argument, they're completely ignoring the fact that human technology is releasing carbon at an insane rate. As far as the geologic timescale goes, it's unbelievable how fast we've by burning coal or just by drilling for oil, and burning that, it's unbelievable how quickly we've released that into the atmosphere. So yeah, so both are correct. It has existed since prehistory, but it also is accelerated immensely, especially after the Industrial Revolution. It's accelerated immensely with that technology, and it's just it's a big problem. So, and I feel like as far as the ocean goes, corals are the chronicle of it, or the best ocean chronicle of global warming, because coral bleaching is temperature related. So I think the statistic is around half of the world's reefs are either in danger or bleached. So it's just that is the chronicle of what's kind of happening. As far as the rate at which humans are releasing carbon in the atmosphere is unnatural compared to how the rest of the natural world has evolved. Corals, if we didn't touch fossil fuels, the corals would be fine. The corals would not be bleaching the way that they are now, because the corals are just evolved not to do that. They're evolved to be in their stable tropical environment and grow at a natural rate and continue growing at a natural rate. But because of the unnatural rate of carbon release and how it indirectly impacts global warming and raising water temperatures, creating a greenhouse effect, corals in turn get too hot. The zooxanthellae, the algae in them, leave. They panic because they don't like the temperature rising, and the corals start bleaching. So yes, Mingus, the natural cycle takes tens of thousands of years, not 20. Absolutely. So again, it's really good that there's more self-awareness now, and there's things like the Paris Climate Agreement. Corals are the canary in the coal mine. Yes, so it's it's good that we have these agreements, and it's just it's good that we have awareness. And I will say, as an American, it's really sad that the United States has not been good about it. I'm just gonna admit, we have not been good about agreements like that. And then also, before the Americans yell at me, not you guys, but just future viewers who are very patriotic, I say that fully embracing the fact that America has been very, very good at state parks, national parks, wilderness areas, marine protected areas. There's a lot of things that America gets right as far as conservation goes, and as far as the science of conservation, and as far as the movement environmentalism goes, there's a lot of things that it gets right. But there's a lot of things it's also getting wrong. As far as just how it, I think we were one of the few countries that refused to join the Paris Climate Accords, and every other Western country did, and it's oh my goodness. So I won't get down into that rabbit hole, but it's just yeah, it's I think the overall point is, when you look at the whole world, there is more self-awareness than there was before, and it does have an impact. It has an impact as far as a lot of newly constructed buildings are greener. Solar panels and solar energy is becoming more and more common. We have electric cars, much more common. It's kind of funny. When I was a kid in the 90s and 2000s, I didn't think that we would have a large amount in my lifetime. And now Teslas are really popular, or even hybrid cars are pretty common. So it's just like we're doing that changing. The question is the change gonna happen soon enough for the survival of certain species, especially for sharks. Are we going to have some shark casualties, or will we be able to kind of convert into a more sustainable mode of living? As time goes on, and we get more and more efficient, and will all the sharks be there? I don't know. So it's pretty interesting to talk about. And then also one more really random note. Kind of related to all of this. So when you think about video games, or like handheld video games specifically, the energy usage has become more efficient, which is kind of cool to think about. Or actually, if you think about even TVs, like because when you think about the technology of like tube TVs, or I don't even know how you do like what the actual terminology is, but like TVs with like the tubes or the bulbs in them, like the big chunky ones, like the VHS. Actually, this is like big chunky TVs with VHS players, or as far as video games go, like Game Boys with the batteries. Like when you look back, those are not very energy efficient technologies, and as time has gone on, both of those things have become more and more energy efficient. Where it's like, for example, smart TVs now, or just the flat screen TVs, they actually conserve a lot of energy compared to the ones that came from the past. And they have streaming. So you're not plugging in a separate device for like a Blu-ray player or like a VHS. You have just this one thing streaming the content that you want to watch. As far as video games go, you got the Game Boy and then the Game Boy Advance, as far as handheld games that use these batteries. And then as time went on, you had the DS, which actually plugs in and charges and recharges. And then a 3DS, which actually charges and is a little bit more efficient. And like the technology gets a little bit more and more efficient as it like develops, which is kind of cool to think about. And it was something that I took for granted. I didn't really realize that, that's an example of technology like getting better, like for our pleasure and our entertainment, but it's also getting more energy efficient and ultimately friendlier for the environment. So you don't have these like big chunky devices just sucking up all this power to produce something like not really that good as far as like graphics or quality or frame or whatever. And then as time has gone on, you've got these more efficient things that make us happier, but they're also actually greener in the long run. They're more energy efficient, so it's kind of cool. And finally, connected to that, it's cool to think that you can have these technologies that have that positively impact human quality of life, and that ultimately this source of electricity can all be connected to like solar panels. Like if you have a house modified for solar panels. So, sorry. Quackers, the 3DS has a revamped version of Luigi's Mansion 2. That's actually really awesome because I think we need some levity. I've been kind of rambling on the environment for a while now, so I think that's a good cap on that. But I loved the original Luigi's Mansion when I was a kid. That is a quality game. Luigi deserves his own game in his own right. And actually, I would rather play Luigi's Mansion than Mario. But that's just me personally, because I know Mario is super popular, but I'm glad that his brother got some recognition. So I have not played Luigi's Mansion 2, but I'd love to check it out. That reminds me, there's the new Endless Ocean game, which I have not played yet, but I've heard it's okay. I've heard the older games are better, but maybe they'll do some updates, and maybe they'll kind of improve the quality. But I am excited to check that one out. So yeah. All right. Also, please leave a comment on the shark you'd like to see next week. I'm trying to think of suggestions, because we're doing really good. This has been a great deepwater episode on the Lanternshark. Also, I don't think we'll have time for this, but I do want to shout out this website, Ocean Today from NOAA. This was a really cool collection, and I'll put this in the chat. A really cool collection of bioluminescent videos. These are all pretty pretty light. Also, let me get that music going again because I love Subnautica. But these are all pretty light, quick watches that are a nice little dive into kind of like some of the science of deep sea and how bioluminescence works. So I'll just leave that in chat for future viewing. So I'll put some suggestions in. Let's see. So new sharks. I feel like I'm just kind of going through the book, and actually, while I do this, I'll go through the book with a suggestion because it might be good to. I might handpick a shark for next week. Let's see, because it will be our contest week. So let's see what we got. I already did Woebegons. We're gonna save the white shark for episode 100. I've got my eye on some bullhead sharks. We've already done a lot of saw sharks, so we might save that for a later day. I thought there was one that I wanted to check out, like a group we've been kind of overlooking. Whoa. Whoa. Okay, I've got one. Whoa. Wow, there's a lot of cool. Okay, I've got two. I just want to see if there's anything else. Okay, so let's see what we got. Alright, there's these two, these are not true cat sharks, these are finback or false cat sharks. Wow, and both are beautiful. Alright, I think we should maybe do a vote. So, here we go. I'm gonna pull up these species. And we'll search Fishbase, because Fishbase should be pretty good about this. So, the first one is the Harlequin cat shark, Tenacious felmani. So let's see. Make sure I got that right. Alright, Fishbase. Sometimes Fishbase is a little junky, but we'll see. It's searching, it's thinking. I love Fishbase, by the way. It's such a personality, because it's like, it can be a little janky, but it's the website, it's the backbone of so much shark, or so much fish research. So this is a Harlequin cat shark, which has this really beautiful pattern, and in life it's like this really bright orange spotting, so that caught my eye. That's option one. So Harlequin cat shark, also a really beautiful name. And then the other one is the magnificent cat shark. Proscelium magnificum. I mean, that's quite a name. I'm almost like that might have to be it. Okay. This might be a good example. And this is kind of faded, if this photo shows up. That's not going to show up, is it? Maybe this photo? Okay. It's a little bit a view of what was kind of catching my eye. It's a really gorgeous color pattern on this species, and in life, it actually looks almost like a leopard shark. So this is the magnificent cat shark. And it's also kind of exciting to see. There's, at least on FishSpace, there's actually quite a few photos. So let's see. Both sound interesting. I love that. Almost as if it's demanding we choose it. Oh, well, we have to do... I agree. I think the Magnificent Cat Shark is a good one, especially since, you know, when you looked at the two sharks, the Harlequin and the Magnificent Cat Shark, the Magnificent Cat Shark immediately has a lot more photos. So that is encouraging that it actually may have more video as well, and that there might be more information on it. So let's do this one. Let's do the Magnificent Cat Shark, Proskylium magnificum. I also think that really fits in very well for next week, since it will be the stream announcing the winner of the Shark Week 2024 banner contest. So yeah, we'll do this one. I'm gonna copy and paste. Awesome, Howard, Magnificent Cat Shark, Mingus Magnificent. I feel it too. I think Quackers made a comment demanding that we choose it. So yes, Magnificent Cat Shark. Proskylium magnificum. So that is going to be next week's shark, and I think it's an excellent pick. So next week will be the Magnificent Cat Shark, Proskylium magnificum. So all right. It's 10:45, so I think we have some time to check out at least one or two articles of the Dwarf Lanternshark. This has been a really fun stream. I've really enjoyed covering the species. So this article, we won't be able to get the full text, but I just want to see if there's any tidbits of information that we can get. Lantern sharks have low commercial value. Existing information from waters of South American Caribbean revealed the catches were largely dominated by a single species of dwarf lantern shark, suggesting comparatively high abundance relative to sympatric species such as Etmopterus robinsoni and Etmopterus hilianus. Hilianus. Hilianus is actually a pretty famous lantern shark species. Let's see. In comparison, existing information on Etmopterus in the Caribbean is very limited, posing questions on the spatial distribution of the species composition throughout the broader regions of the Western Atlantic. Interesting. Can we see... So here's a bathymetry of the Colombian coast. So the darker shaded areas are deeper water. So it's kind of cool to see there's like really deep pits or holes. It's kind of a unusual looking marine geography. It's really cool, or at least unusual to me. It's okay. I think there was one article that kind of caught my eye. Deep sea fish assemblages in the Caribbean Sea. It's not this one. Oh, it's kind of cool. Colombian sharks. It's kind of cool to see there's a lot of familiar faces. Blue shark. A lot of hammerheads in Colombia. Serena Corona, Luini, Media, Macron. So great hammerhead, scalped hammerhead, bonnethead, small eye hammerhead. It's really cool. Mako sharks. Whale shark. So, yeah. But we'll kind of keep looking. There was one article that stuck out to me. This one. This was it. Right, okay. We might have seen this before. This is Shark and Ray Diversity in Tropical America, an examination of environmental and historical factors affecting diversity. So if I remember this correctly, this is talking about how in this part where you have like the very narrow land bridge as Panama. Once upon a time, these two, like this area was underwater, and so there's a lot of similarity in the biodiversity between the elasmobranchs on the Pacific side of the Americas and the Atlantic side of the Americas. However, once that bridge formed, it affected the total biodiversity, where the Caribbean and Western Atlantic actually has more species than the Pacific, if I remember correctly. So it's a really cool article about kind of showcasing the difference on these two different sides of the Americas. So let's check this out. I think this is a good one to maybe wrap up for the night. So this is by Jorge Domingo Carrillo Briceño, Juan D. Carrillo, Arendel Antonio Aguilera, and then Marcelo R. Sanchez Villagra. So, we present the first comprehensive review of the present and past shark and ray diversity in marine waters of tropical America, examining the patterns of distribution in the eastern central Pacific and western central Atlantic realms. We identified the major regions of diversity and of endemism and explored the relations to physical variables. We found a strong relationship between shark and ray diversity with area and coastal length of each province. The tropical northwestern Atlantic province is characterized by high diversity and greater occurrence of endemic species, suggesting this province as the hotspot of sharks and rays in tropical America. The historical background for the current biogeography is explored and analyzed. Referential data from 67 geological units in 17 countries from both shallow and deepwater habitats across 5 time clusters from the Miocene to the Pleistocene were studied. New data include 20 new assemblages from 6 countries. The most diverse neogene and extant groups of shark and ray are Carcharodontiforms and Myliobatiforms. This is really cool to see because Carcharodontiforms really exploded as far as shark evolutionary history, and it's like the dominant. It is the dominant order today as far as like the sheer number of species. So it's kind of cool to see that there's that reference to that as well. The differentiation between Pacific and Atlantic faunas goes to at least the middle Miocene, probably related with the increasing closure of the Central American Seaway acting as a barrier. So this is when you have the creation of like Panama, or just like closing that area up, and you have that terrestrial division from separating the Caribbean from the Pacific. The highest faunal similarity between the assemblages from the eastern Pacific and the western Atlantic at the early Miocene could be related to the lack of a barrier back then, but increased sampling is needed to substantiate this hypothesis. So this is a really cool study. So again, the root of these, a lot of the families on these two sides of the Americas, they're similar, or they're kind of rooted in a similar evolutionary history, but the biodiversity has differed as far as like the Atlantic has more than the Pacific as a result of like that land bridge. It's cut the two groups off, and the Atlantic has been able to evolve at a more rapid rate. Or there's something about the spatial area where I think what they're saying, if I remember correctly, because this area is more embayed, like when you go up and down the coast, there's more surface area, because you have like more embayed sections, so there's more chance for species to evolve. Whereas like here is a little bit more, it's comparatively a little bit more linear, so it's a really cool study. Let's see. I just want to pull up any graphs we can see. The reason this article came up is, of course, oh, there we go. The reason this article came up is because the dwarf lanternshark it's included in this one, the temperate northwest, the tropical northwest Atlantic. So it's cool. And it's cool how they break this down. I think these are breaking this down not into ecoregions, but into provinces. Yeah, provinces, marine provinces. So these are larger levels of ecosystem. So you have the tropical Northwest Atlantic, the North Brazil Shelf, the tropical Southwest Atlantic, the warm temperate Southeastern Pacific, the tropical Eastern Pacific, and then the temperate Northern Pacific, temperate Northern Atlantic. And the Galapagos. The Galapagos is its own thing. That's really cool. This is really cool to see. This breakdown is based on really critical environmental variables. I'm not as familiar with this area, but I will say you can separate the tropical Atlantic from the temperate North Atlantic based on temperature. So in this part of southern Florida, southward, it's more stable. It's more tropical. There's less seasonal variation. When you get north of this line, you get more of your seasons, like winter, spring, summer, and fall. South of this line, you get kind of like warm, wet season, dry season kind of thing. Down here, my guess for the North Brazil Shelf is probably a lot of influence from the Amazon. So the Amazon River creating a lot of sediment load into this area. So you probably have more of an influence from that, and you don't have something quite like that in the Caribbean area. I really don't know what makes the tropical Southwest Atlantic different from the North Brazil Shelf, but the Amazon River's influence is a guess that I have. So, but it's a really cool biogeography study. Let's see if there's anything else. Oh, and it goes into fossil diversity, which is so cool. Okay. I'm just kind of scanning through this because I know it's almost 11. Oh, man. Actually, and I'm going to include this article in the chat as well because it's a really cool one. So, oh, Crackers, Sorry, I just saw your comment. South Padre Island. So I have not. I heard briefly about it in Texas, but let's actually check that out really quick because. I think the rest of the articles I have, there's not really a lot. Oh, actually, we will read this one because it is about our species specifically. So we will do this one before the night ends. So let's check this out. South Padre Island shark. I don't want to click a news article because man, I'm trying not to click a major news article because unfortunately all of them are just like so bogged down by ads that they're almost impossible to navigate and they're going to slow down the bandwidth. Associated Press is pretty good. They're usually pretty good about that, so I'll just do this one. Shark attacks reported at Texas South Padre Island. 2 people bitten, at least 1 severely. Wow, look at that. So from first glance, this is kind of a fuzzy photo. My guess is this could be a sandbar shark because the dorsal fin is huge. Can you get out of here, Biden? Don't know, and I don't know who that is. Sorry. Okay, you do get some odds. First glance, this could be a sandbar shark, which is not really a dangerous species, but this could be a sandbar shark because the dorsal fin is huge. It could be a bull shark, depending on the proportions. But I think, and this is such a fuzzy image, since the dorsal fin is quite triangular looking, this is just so big that I think this particular photo is a sandbar shark is my guess. So, okay, and this is probably not the shark that was responsible. Wait, is this it? Shows sharks near the shore. This is probably not the shark responsible. This is probably a sandbar shark just cruising in the area. So. Let's see. Severely been 11 a.m. Oh wow, middle of the day. That's actually kind of unusual. A lot of predatory sharks. I mean, it can happen. A lot of predatory sharks, like bull sharks, they like to be in deeper water during the day, and they'll come out into shallow water at night. So it is a little weird, but it's not like. I mean, there's so many records of shark attacks in the middle of the day anyway. So I mean, it's not like, I guess I shouldn't say it's unusual, but like bull sharks typically do want to be in deeper water during the day, and they usually patrol shallow water at night. But oh, no ads. Oh man, Associated Press, you're letting me down. Bitten 2 more encounter shark but not seriously hurt. Single shark about 6 feet. Oh, okay. Yeah. So, yeah, I'm not sure if it's like an investigatory bite. I mean, so that area is very murky. Here, I'll get out of here because all these ads are jumping on. So, if that area is like very murky, it could be mistaken identity. It could be like a sandbar shark or like a hammerhead kind of rushing at a hand in the water thinking it's like a fish. If it is and like 6 feet, I mean a lot of sharks can be in that size class, including bull sharks, but I mean, it could be a lot of things. I mean, you know, if you're in murky water at this time of year, I mean, it could be like a tiger shark, a bull shark, probably not a great white, because that's not really where they like to be this time of year. I don't know. It could be a lot of different species, but I don't really know much about. Like I heard that incident happened, but I don't know a lot of details. In other articles, did they identify the shark or? Oh, Mingus, yeah, definitely agree. The ads are really getting unbearable. I definitely agree with that. So I don't have a lot of information about South Padre Island. I do know that that area operates pretty similarly to like the Mid-Atlantic in the summer. It has more shark species, like there's Caribbean reef sharks, and I think you can get like small tail sharks. But as far as the actual species, I would guess it's probably either a sandbar shark or a kind of hammerhead as a case of mistaken identity. Probably like a sandbar shark. Or it could be a bull shark or a tiger shark. Because like those species do occur. I don't think it would be a great white, because that's just, they're there, but and they could be there any time of the year, but like they really don't spend a lot of time, I feel, in the Gulf Coast in the summer. You know, if we were in Massachusetts, I would say something completely different as far as, you know, definitely very likely a great white. But like, yeah, warm waters, warm murky waters. I would wager it's probably a bull shark, like a bull shark, sandbar shark, or maybe a kind of hammerhead, maybe a sand tiger. But those are usually very docile. So yeah, but that's really unfortunate. That's really sad that happened. Yeah, if you guys learn anything about it, if they identify the species, please let me know. The one in the photograph looks a lot like a sandbar shark just because the dorsal fin is so huge. So, but anyway, I think we'll wrap up with this, and then we'll call it a night. So, a matter of size, the population structure of the smallest known living shark, Etmopterus perryi, from deep waters off the Colombian Caribbean coast, by Jorge Barramo, Rodrigo Whiff, and Rina Gonzalez. So, the dwarf lanternshark is the smallest known described shark, and practically no information has been available on this species since first described in the mid-1980s. Therefore, the aim of this work is to describe for the first time the population structure regarding dwarf lanternshark in the Colombian Caribbean Sea. During deepwater research surveys conducted along the Colombian Caribbean coast, 87 stations were sampled using a swept area method. A total of 153 dwarf lanternshark individuals were caught in depths ranging from 230 to 530 meters. This information was used to describe the size structures, morphological measurements, including weight, length at weight relationship, length at maturity in females, and the spatial distribution of mean length and biomass of the species. We'll kind of scan through the rest. Oh, yeah, sorry. The length of the individuals range from 78 to 289 millimeters total length, which is a new record of maximum length for the species. So 29 centimeters, so still very small. The spatial distribution of mean lengths and biomass distributions show high abundances and high relative mean lengths in the northeastern area off Santa Marta and the area northwest of Rio Hacha. The mean biomass density in the whole prospect area was 5.52 kilograms per kilometer. a square kilometer. Length of 50% maturity in females estimated as 203 millimeters, so 20 centimeters. Deepwater elasmobranch species such as the dwarf lanternshark are expected to show extremely low resilience to fishing exploitation, even when they're not targeted by commercial fishing. So that's actually really important. And let me read that again. Deepwater elasmobranch species such as the dwarf lanternshark are expected to show extremely low resilience to fishing exploitation, even when they are not targeted by commercial fishing. Therefore, the information reported in this study can serve as a baseline upon which management measurements can be proposed for the conservation of this shark species. So, glad we read this. This is a really important study. Pretty fresh, 2021. So, really cool that there's this piece of research that can do exactly what they said. It could be a baseline for conservation should we feel that the dwarf lanternshark may one day be in trouble. So, but yeah, let me go back to our Mark Dando illustration and we'll call it a night. So, man, thank you guys so much for watching. I had a lot of fun with the dwarf lanternshark and just deep sea science in general. So it was really cool to spend this time with you guys exploring the Twilight Zone. I actually did dim the lights and everything just on purpose because I thought it would be kind of fun to get in the mood for just like deep water sharks in a deep water environment. This also was a really good conservation episode as well. And I really like that. It's cool to see as years go on. Like last year, biodiversity was a theme. I think this year, conservation has really become a theme. So I really enjoyed kind of learning how 2024 has developed with our community. It's been a lot of fun to dive into that more tonight. But this is the last stream before we announce the winner of our contest. So best of luck to everybody. I'm excited to see what you guys make for the Shark Week banner contest. Really great prizes for our grand prize as far as like a megatooth shark fossil. 2 really great shark books. I mean, I should not praise myself because that's a little egotistical, but at least 1 really fantastic shark book, and the banner of your design showcase as the official banner of Dr. Jaws for the next calendar year until we get to next Shark Week. So, Howard Kerr right now is our reigning champion, and will he maintain it for 2024? Will we have a new champion? Will we have a new champion for 2024? We shall see. Either way, I'm very excited to see your guys' art. So, thank you, Minjas. I just saw your comment about the face cam. So, but best of luck, everybody, and most importantly, I hope you all have fun with your artwork. And please send me anything you got. I'm really excited to see what you create, and I'm just super excited for this year's banner contest. So happy Shark Month. I know Shark Week is officially over, but we're just going to extend it for the Dr. Jaws stream. July 21st, Sunday. This Sunday is the deadline. So send it to Dr. Jaws. I'll just type the email here, drjawssharks@gmail.com. And we'll announce the winner next Monday with the magnificent cat shark. So have a great week, everybody, and I will see you next week with the results. So good luck. Happy Shark Week. Happy Shark Month.